Saturn V Quarterly Film Report Number 5 covers progress from December 1st, 1963 through February 29th, 1964, highlighting Saturn ground test stage construction. S-1C efforts at the Marshall Space Flight Center this quarter were primarily in support of the test fuel tank and the static firing test stage. Following completion of fuel tank assembly last quarter, the liquid oxygen tunnel for the tank was trimmed, fitted, and welded into the bulkheads in January. Later, S-1C tanks will each have 5 such LOX tunnels. Structural assembly of the aft adapter for the test fuel tank was completed in early February, and the adapter was placed in the vertical assembly building pit for mating with the tank. Marshall's hydrostatic test tower, part of the vertical assembly building, was used for the first time in early February during hydrostatic pressure testing of the test fuel tank. The tank was filled with some 225,000 gallons of water, weighing approximately 2 million pounds. Pressurization totaled 30 psig at the lower bulkhead. The tank was instrumented with some 250 strain gauges and deflection transducers in areas expected to experience high stress. A fluorescent dye, which glows under ultraviolet light, was mixed with the deionized water as an aid in checking for any leaks around weld seams. Following the successful pressure testing, the tank was lifted from the hydrostatic tower by means of giant cranes and set down on top of the aft adapter for mating to it. Mating was by means of mechanical fasteners. The aft adapter and the forward adapter, half of an intertank, are special items to permit structural testing of the tank. In assembly operations on the S-1CT, welding of the upper fuel bulkhead to the Y-ring was begun out of sequence in order to make optimum use of tooling while weld certification tests were being conducted to solve problems encountered during final assembly of the lower bulkhead. The lower fuel bulkhead to LOX tunnel extension weld and the upper fuel bulkhead polar cap weld had both been rejected and removed. Welding of the S-1CT lower fuel tank cylindrical skin assembly was completed during the quarter. All skin sections were available for the upper fuel tank cylindrical skin assembly, but welding was held up until completion of the weld certification program. Assembly operations on the S-1CT thrust structure continued at the Marshall Center during the report period. The 4 thrust posts, delivered to Marshall in early January, have been fitted and installed in the thrust structure assembly fixture. The thrust structure is scheduled to be completed in June 1964. Assembly of S-1C mock-ups continued at Marshall this quarter, with installation of the control pressure system in the forward and intertank mock-up virtually completed. The basic heat shield support structure has been assembled and installed in the tail section mock-up. At Marshall's S-1C static test stand, all major welding on the load platform has been completed. The 1,900-ton deflector has been rolled into its normal position and is being rigidly fastened to the supporting base. Cable installation in the 150-ton derrick is complete. Site work around the test stand and support building is continuing, with approximately 60% of the concrete sections poured. Assembly of the S-1C transporter was completed at Marshall this quarter. Mechanical, hydraulic, and electrical checkouts have been performed. The 100-ton transporter, which has a total of 24 wheels, consists of 2 dollies which will be bolted to the ends of the self-supporting S-1C stage. Road tests will start next quarter. At Marshall's Michoud operations, Boeing's S-1C activity this quarter included fabrication of the 16.5-ton forward handling ring, a tool which will be used in all phases of movement of the S-1C stage. Although the ring failed in its initial test in Michoud's proof load facility, later tests following repair were successful, and the ring was sent to the Marshall Center. The final 2 rings are now being assembled at Michoud. The S1CT intertank was completed at Boeing Michoud during the report period and will be shipped to Marshall shortly. 6 60-degree skin panels are joined on the intertank final assembly fixture to form the connecting link between the S1C locks and fuel tanks. The S1C forward skirt assembly fixture has been installed at Michoud by Boeing. The skirt assembly, which will be made here, functions as the connecting link between the S1C stage and the S2 stage. Michoud's vertical assembly building construction is now completed. Final work this quarter included installation of the 180-ton capacity overhead bridge crane. Installation of tooling and test equipment is presently underway. At Boeing's plant in Wichita, Kansas, S1C support work, such as this routing of fuel tank fittings, continued during the report period. At Boeing Seattle, a welded LOX tunnel 40 feet long and 25 inches in diameter was fabricated on a crash basis when difficulty was encountered in properly heat treating the seamless tunnel. At the Seal Beach facility of North American Aviation Space and Information Systems Division, S2 structural test stage assembly progressed this quarter with the aft common bulkhead completed in February. Construction of the vertical assembly and hydrotest building at Seal Beach is now more than 80% complete. The structural static test tower is more than 55% complete. Steel frames, stairways, handrails, and walkways have been erected to the 130-foot level. At the Santa Susana Propulsion Field Laboratory, construction of the all-systems test stand is virtually complete, with ground support equipment and control equipment wiring being installed. At the battleship test stand, the service tower and the flame deflector are complete, and the spillway has been paved. In late December, the battleship LOX tank was filled with liquid nitrogen and a chill test was conducted. The purpose of the test was to evaluate effectiveness of the flexible seal that surrounds the LOX tank and to determine how well the seal adheres to the tank when subjected to cryogenic temperatures. Test results indicated there was no leakage around the seal. At S&ID's facility at Slauson, California, tooling for the manufacturing of S2 bulkhead subassemblies was installed this quarter. Separation testing of a full-scale simulated S2 interstage skirt section was successfully accomplished by S&ID at Downey. Objectives of the tests are to verify that the linear-shaped charge separation system is satisfactory for structural integrity and functional operation. Quarter-scale liquid hydrogen test tank number 2 was delivered to S&ID's Downey facility on December 31st by the subcontractor. Later, the tank was pressurized with helium, 7.5 psig, and each weld seam was checked with a mass spectrometer leak detection probe. No leaks were detected. At Douglas Aircraft's Sacramento test facility, S-4B battleship tank pre-installation preparation was completed, and the stage was installed in beta test stand number 1 on December 18th. Water calibration of the battleship tank was completed successfully later in the report period. Installation of exterior components is underway and will continue next quarter. Construction of the all-systems test stand Beta 3 continued this quarter with installation of structural steel and building of propellant storage tanks. Initial ground support equipment for the Beta Control Center arrived during the report period and was installed. Completion of GSE installation is scheduled next quarter. This manual GSE will be converted to automatic for acceptance firing of S-4B stages early next year. Construction of Complex Gamma at SACTO is now over 75% complete. Complex Gamma will be used to static test S-4B auxiliary propulsion modules. The complex is scheduled for completion next quarter. At the Douglas Huntington Beach facility, the liquid oxygen tank assembly for the S-4B hydrostatic test stage was installed in assembly tower number 1 this quarter. The tank assembly had been fabricated at Douglas, Santa Monica. After movement of the hydrostatic test stage liquid hydrogen tank into the tower, welding of the tank to the LOX tank was accomplished and the forward dome was welded on. Later, the entire propellant tank was moved to assembly tower number 2, where machining of skirt attach angles will take place. Next quarter, the stage will be cleaned and hydrostatically tested. Assembly of the dynamic test stage was also begun this quarter at Huntington Beach. The LOX tank assembly received from Santa Monica was positioned in assembly tower number 1. The liquid hydrogen tank for the dynamic test stage was positioned for welding as the quarter ended. The stage will be shipped to the Marshall Center in December 1964 for dynamic testing as part of the Saturn V vehicle. Propulsion system testing of the first F-1 production engine, built by Rocketdyne, began at the Marshall Center this quarter in the modified S-1 static test stand. A total of 14 static firings was conducted for a total main stage time of 403 seconds. The longest firing was for 122 seconds. About 175 engine and facility performance measurements were recorded during each test. The firings will continue next quarter. At Marshall's F-1 engine test stand, erection of steel superstructure has been completed and the 100-ton derrick has been installed. Siding installation on the elevator tower is in progress. The deflector is complete except for minor welding and painting. Technical systems and utilities installation is continuing. The preparation building has been completed and occupied. At Edwards Rocket Site in California, a fully operational heat exchanger was installed in F-1 engine 014 this quarter for testing. A number of successful system tests of production engine number 2 were held during the report period in test stand 1B1. At Rocketdyne's new manufacturing building number 3 at Canoga Park, F-1 engine assembly and checkout are now being carried on full-time. Facilities here allow for building 4 engines simultaneously. Modifications to the water high-flow test facility to increase its capacity were performed this quarter, with piles being driven down to 65 feet to anchor the test run piping. The increased capacity will make it possible to obtain flow information on F-1 injectors and components at closer to normal operating conditions than previously. Long-duration static firing tests of the J-2 engine were continued by Rocketdyne at its Santa Susana test area during the report period. The Delta 2A position was activated in December. In Rocketdyne Structures Lab at Canoga Park, a hydraulic gimbal test machine has been placed in use to test the J-2 engine gimbal bearing assembly in cycling operations. Testing of the J-2 thrust chamber assembly determines thrust chamber and component deflection under given load conditions. In Rocketdyne's vertical alignment stand, the thrust alignment of the J-2 thrust chamber is determined through a series of optical and circumferential measuring guides. The geometric center of the chamber is located so as to be coincident with the center of the engine gimbal block. At the Marshall Space Flight Center, construction of the Saturn V dynamic test stand continued this quarter, with tower steel erection having reached the 9th or 216-foot level. Excavation for Tunnel B has been completed, and forming for pouring the tunnel floor is in process. The brick and mortar portion of the fan room in Tunnel A has been finished. Miscellaneous work about the stand and termination building is continuing. Blockhouse excavation for Marshall's Saturn V ground support equipment test facility was completed this quarter. Test area and roadway grading are continuing. Construction progressed this quarter on Marshall's new load test facility, a 30 million pound capacity test tower capable of testing S1C stages. The tower is now up to its full height of 140 feet, and work is underway on the 155-foot tall hangar-type building which will house it. At Marshall's Mississippi Test Facility, construction moved ahead steadily at the three main complexes and on the roads and waterways serving them. The construction dock at MTF has been completed, and the cryogenics dock is now over 50% finished. At the Support Services Complex, construction progressed on the warehouse, site maintenance building, emergency services building, central heating plant, 115,000-volt electrical substation, and telephone and communications building. At the Laboratory and Engineering Complex, work is underway on the Lab and Engineering Building, which will serve as Mississippi Test Operations Headquarters. And at the Test Complex, work continued on the S1C test area and the S2 test area.